Okay, good afternoon. So itutuloy lang natin yung discussion natin, no? So last time, I have shown yung or na-discuss ko yung 1.3, which is yung simple random walk in one dimension. So pinasimple natin yung problem na in-illustrate natin na using a drunkard walking along a street. We simplify that by thinking of the man as a particle na ang probability niya moving to the left and right is just the same, which is 1/2. Okay? And pinakita natin na dinerive natin kung paano makuha yung probability and after some number of steps. Okay? So ngayon, we will discuss yung mean values na. So this is a more broad discussion of mean values. No? If you're familiar with statistics before, or kung naalala nyo pa, ito yung isa sa importanteng characteristic ng mga distribution or sets of numbers. Okay? So mean value is just another term for average. Okay? So when you say mean value, kinuha mo yung average. So if that, like halimbawa, usually kapag may score ka, i-average mo, divide mo by the total number of score. However, kapag may mga other factors like, halimbawa sa inyo, about this sem, bawat course nyo is may number of units, diba? So para makuha nyo yung GWA, you have to multiply yung unit by your grade, and then i-add mo lahat yan and divide by total number of units. Okay? So similarly, ganun din sa pagkuha ng mean values. No? So halimbawa, you have a discrete values denoted by U sub m. Okay? So m, discrete value. So you have U1, U2, so on hanggang U sub m. And then each value has a corresponding probability. So PUI, PU1, PU2, up to PUM. Alright? So ngayon, para makuha mo yung value, mean value or average of U, we denote it usually with a bar sa overhead noong letter natin. So you have mean value of U is just U bar. Okay? So ngayon, to do that, we have to do is to sum all the products of that particular value, like U, multiply by its corresponding probability. So i-add mo lang lahat yan. Okay? And then, divide mo sa total number of probability. Alright? So isasum mo naman itong mga ito. Okay. Galing ko lang. Okay, so shorthand notation niya, of course, in summation ito, madali lang isulat. No? So you have summation over I to M of P of U sub I times UI divided by the summation of PUI. Alright? So, yan, nabanggit ko nga kayo na similar ito sa pagkuha ng UWA. So, not necessarily naman probability. In this case, kasi this could be as other factors. Okay? Alright, so continue natin. Ngayon, example, if you have a number of discrete variable, let's say U is equal to 2, 3, 4, 5, 6. And of course, in probability distribution is given by this particular function. We have P of U is equal to U squared over 90. Ngayon, una, let's construct the probability distribution table for U and then calculate the mean value. All right? So, para makuha natin yung probability distribution, all we have to do is to create this table. So we have all the values of U on this row. Okay? And then the values of P of U, this one. So madali lang, ipapalit mo lang sa U squared over 90. So makuha mo agad yan. So we have the corresponding probabilities here. To calculate the mean, all we have to do is follow the formula. So we have, yung una, we have 2 times the probability, which is 4 over 90, plus 3. Ito yan, multiplied by 9 over 90. Okay, plus 4, multiplied by 16 over 90. And then 5 times 25 over 90, plus 6 times 36 over 90. Okay? Right. So ngayon, yung denominator is just the sum of all the probabilities. So i-add na natin itong mga to. Okay? So once you add that, makikita natin actually na this will just be equal to 1. Alright? Which is tama kasi we are dealing with probability. So of course, the total sum should be 1. Alright? Otherwise, mali yung given probability distribution function. Okay? So approximately, this is equal to 4.888 over 1. So ang mean natin is around 4.89. Okay? So yan lang yung pagkuha ng mean sa given a probability distribution function and some discrete values. Okay? Generally, that particular u variable could also be given as a function. So halimbawa, instead of u, we have a function of u sub I. So papalitan mo lang din yung factor na yan with this particular. So you can actually get the average of the function. So ayun nga, since yung probability, sum ng lahat ng probabilities are just equal lang sa 1, we can just remove this. Okay? Of course, in other sets like score or grade, this can never be equal to 1 dahil nga hindi naman probability yan. You still have to use this particular formula. A special case lang, since we're dealing probabilities, this particular term is just equal to 1. Alright? So this is the normalization condition. No? Kung naalala nyo, sa QM, we normalize the wave functions. Kasi nga, di ba, when you square the wave function, it will give you the probability. And that should be equal to 1. Okay? So now this is the general form for the average of a function given its probability distribution. Okay? However, if you have more than one function, and if you want to get the sum or the average of their sum, like average of fu plus gu, you just have to do it algebraically. I-add mo lang din. So magkakaroon ka lang ng term na ganyan, and you can further separate them. And of course, you can see here na ang average ng sum is just the sum of their averages. Okay? So ganun lang siya. Okay. So moreover, if you have a constant c, you just get, multiply mo lang yung average ng function times just the constant c. It's just the same. Okay? So yung mga mean values na yan, hindi lang siya simpleng kagaya nun sa average lang. Meron din tayong tinatawag na iba. Like, meron ding mean tayong tinatawag na yung kagaya nito, delta u, pwede nating i-average yan. Delta u is related to the dispersion noong wave, not wave function, noong distribution function. Of course, this is related din sa wave function natin na dinidiscuss before. Okay? So halimbawa, if you have a certain value u, pwede natin siyang i-reference sa mean, no? So you have u bar. So yung dispersion niya is u minus kung gaano siya kalayo sa mean. Yun ang ibig sabihin yan. Now, if you want to get the average distance na yun, which is delta u, i-average mo, no? So you have to average this whole thing. So lalagyan mo lang ng bar itong dalawang ito, which is just the same as this next equation natin. So ngayon, general rule, kapag nagbabar ka ng expression, so para siyang madidistribute, no? So you have here, you have u bar minus u double bar. Okay? So since this is just the average, sunod mo lang na siya as u bar. However, itong ikalawa, kahit dalawang bar yan, what is the average of the average? It's just the same. So constant lang din. Therefore, this is 0. Okay? So yan yung delta average layo niya sa mean. Okay? So, ibig sabihin nun, yung mean value of the deviation, ibig sabihin average deviation from the mean vanishes. So, halimbawa, you have a parang distribution function na ganyan, no? Wait lang, ayusin natin. Okay? So, halimbawa, ito yung mean mo. Itong nasa gitna, no? let's say this is U bar. And this is your, let's say, delta U. Okay. In general, the other values have also may mga delta U din dito, no? Ngayon, ibig sabihin lang nito, kapag lumalayo ka, kapag in-average mo lahat ng mga to, nag-zero siya. Okay? So, yan. Next. So, itong delta U natin is also called, or yung average, sorry, pwede rin pala natin siyang kunin yung average ng square. Okay? Sometimes mas depende sa characteristic ng wave function mo. You can get the average of the square. So, ganun lang din siya. All you have to do is sum the product of the probability times ui minus yung deviation niya from the average. So, square na siya, no? So, important thing to note here is, di ba yung u bar, delta u bar is 0. However, yung delta squared bar could also be equal to 0, but sometimes also greater than, no? Okay, so this is called the second moment of u. Moment, second moment meaning dahil naka-square. This could go on to higher order din naman, like 3 or 4, etc. Okay, so simply pwede na siya tawaging dispersion of u, kung gaano ka-spread yung distribution function. Similar way, kung gaano ka-spread ang wave function, diba, sa QM. Okay, so sabi dito, the dispersion is always positive and vanishes if and only if lahat ng value mo ay equal sa average. No? Ganun lang siya. So it measures how much values of the variable are scattered. So, di ba, distribution nga siya, no? So pwedeng, may mga distribution kasi na hindi naman perfect bell curve, di ba? May mga distribution na naka-skew, like mas malaki sa isang side kumpara sa kabilang side. So, pwedeng nating ipakita yan. So now, let's do that. So to get the second moment, so you just have to get the mean, okay, of that particular expression. We have u minus u bar squared. So since square to, we can expand this. So we have u squared minus 2u u bar plus u bar squared. And then ibabar mo yung buo. Okay? So we can, again, kapag may nakabar siya, we can distribute the bars sa individual expression. So you have u squared bar minus u bar. Since ito magiging u bar bar, magiging u bar lang siya, no? And then we have u bar squared. Since nakabar na rin ito, wala na rin yung bar na yan. So magiging u bar squared na lang siya. So now we have u squared bar minus, since same lang ito, we have 2u bar squared plus u bar squared. So since same lang itong dalawang ito, we can add them. So magiging negative. So we have, now the dispersion, second moment is equal to u squared bar minus u bar squared. Okay? So since pinakita natin na yung dispersion on the left side must be positive. Tama? Kasi positive to, di ba? So this particular component, pwede nating ipakita na mas malaki lagi yung average ng square ng mga variable. Could be sometimes equal din, but most of the time it's just greater than the square of the mean. Okay? So in general, the expression natin kanina sa second moment could be extended to higher order nga. So greater than 2 yung n. So pwede natin palitan. So could be third moment, 3, fourth moment, etc. However, in reality, hindi natin usually ginagamit yon. Sometimes we just need the second moment. Okay? Yung squared lang. Pero you can still solve. Like, palitan mo ng 3, makukompute pa yan. Okay? So, yun nga. So by now, you can see na yung mean is just the expectation value. Similarly, tapos yung delta u squared and delta u are just the variance and the standard deviation. Okay? So yan yung sa general discussion natin ng mean value. So tandaan nyo lang yung mga yan. If you given some data set, you can use this formula to calculate these characteristics. Okay, so ituloy natin hanggang sa section 1.5, which is yung paano natin i-calculate yung mean values ng random walk. So again, sa one-dimensional muna tayo. So earlier kasi pinakita lang naman natin sa 1.3 yung paano natin ipapakita yung distribution, di ba? Hindi natin sinolve yung mga ganito. So now let's solve for the mean values ng sa random walk. Okay? So let's say we have a total number of capital N steps. And again, we all know N1 and N2. It's just the number of steps to the right and to the left respectively. So recall natin yung probability na nasa N1 steps yung particle. So since we know na yung ito ay probability, if you have several values of N1, we can do the summation. So the summation of all Wn1 is just equal to 1 dahil probability lang siya. Okay? So palitan lang natin. Let's use this particular idea. So di ba pinakita natin yung binomial expression before? So we can use this, yung equation 1 to 8, so to W1, into this particular expression. So magiging summation siya, no? Okay? So we have ito pa rin. Nilagay lang natin dito. And since we still deal with P and Q, this is just equal to P plus Q raised to N. Okay? However, since we know na P and Q is just 1/2, ang sum nila ay 1. And therefore, 1 raised to N will just be equal to 1. Okay? So, yan. Ibig sabihin, itong buong value nito is just 1. Okay? So, indeed, pinakita natin na yung probability talaga niya ay equal sa 1. So, ngayon, try naman natin i-calculate yung mean number of N1 steps. So, average number of our steps to the right. Okay? So, gamitin natin yung formula. So, to get the average, you just have to multiply yung respective probability and that particular value. Remember, i-divide pa yan ng sum ng Wn1. However, this is just equal to 1. So, we don't need to do that now. So, pinasimple na lang natin. Okay? Since we alam na natin yung expression for W of N1, palitan lang natin ito. Okay? Ito yun. You just have to multiply it by N1. So, ganyan siya. So, kung titingnan nyo dito sa summation, this is actually quite complex kasi tingnan nyo, summation siya and naka-factorial pa yung iba dito. And mayroon ka pang exponent na N1 and naka-multiply pa ng N1. So, hindi siya ganun explicitly kadaling gawin. So, we can use some trick para ma-solve ito. Okay? So, let's say, pwede nating express, di ba exponent to, no? We are dealing with N1. So, let's say, assume natin yung P and Q are just arbitrary parameter, which of course they are, like 1/2 lang naman sila, no? We can actually use this expression. So alam natin na ang N1 times P raised to N1 is just equal to P times the partial derivative of P raised to N sub 1 with respect to P. Tama? Kasi exponent lang yan, di ba? So, yan yung mangyayari. So when you do you double check this, i-derivative mo lang. So you have, bababa yung N, and then magkakaroon ka ng N-1, multiply mo ng P, babalik ka rin, no? Tama ba? So magkakaroon P, N1, P raised to N1 minus 1. Tama? And this one could be multiplied by to this one. So you have N, P1. So tama lang. Okay? So using this, we can further express yung kanina nating expression for the mean value, which is much more complicated, no? Ito. Palitan natin yung kanina na NP1, which is ito at saka ito. Okay, multiply nito is just the same as this one. Okay? So now, pwede nating ilabas yung derivative, yung expression na ito, no? So dahil nga we are diniderivative natin siya with respect to P, pwede natin i-derivative yung buong summation. Okay? So, ngayon, kung makikita nyo, itong expression na ito is just, equal to derivative of P plus Q raised to N. Okay? So, pag diniderivative mo yan, mangyayari dyan is, magkakaroon ka ng N times multiply mo lang siya ng P plus Q, then bawasan mo lang ng 1. So, ito yung average. So, kung titingnan natin, ang P plus Q, this one, is just equal to 1, right? So, therefore, yung average number of steps to the right is just N times P, which is the probability of taking the steps to the right, which is actually as expected. Kasi nga, halimbawa, you have 10 number of steps, total number of steps, okay, total steps, and you have the probability of going to the right is 1/2. Ano yung chance na tawag dito, ilan yung steps to the right, average? You just have to multiply it. So, ibig sabihin, 5 steps to the right and 5 steps to the left. So, ganun lang siya. Okay? So, similarly, ganun din. So, kapag sinolve nyo, similar dito sa expression na ito, for n sub 2 bar, or the average steps to the left, is just total number of steps times q, which is the probability of taking the steps to the left. Okay? So, we can actually get the sum of their averages. And kung makikita nyo, this is just equal to n, which is the same. Tama? Kung ilan yung number of steps to the left, i-add mo lang the steps to the right. And this is just equal to the total number of steps. Okay? So, now, alam natin kanina yung displacement m, which is the difference between n1 and n2. So, to get the average, ganun din. So, m bar is then equal to the average of n1 minus n2. So, alam natin kanina, we just have to take the individual averages here. And ito, nasolve na natin ito kanina. So, we have np minus nq. So, the total, the average displacement is n times p minus q. However, in our case, we know that p and q are equal. So, this is 0. Tama? Therefore, the average displacement is 0. Okay? Naalala nyo doon sa random walk na tinanong ko, ano yung average position noong drunkard? Of course, since equal yung probability, ang average position niya ay sa origin, which is 0. Okay? Dahil yun sa symmetry. However, if P and Q are not equal, dun ka magkakaroon ng ibang value. Kasi nga, halimbawa, mas mataas yung chance na pumunta siya sa right kaysa sa left. So, ganun. Okay? So, try natin yung dispersion, which is the second moment. So, we have delta n1 squared, average niya. So, ganun lang din. Sundin lang natin yung process. So, we will have n1 minus mean n1 squared, average niya. So, distribute mo lang yung bar, this. So, ibabar mo lang to, so ganun pa rin, no? So, now, this is the expression for the second moment. So, to compute for that, ganito lang din, no? Familiar naman sa inyo to. This is before, pag ginawa natin is PUI times UI kung ano man. Squared. Alright? So, palitan natin. We all know the expression for W sub 1, Wn1, which is this one. Okay? Ngayon, multiply mo siya ng n1 squared. So, similar doon sa trick natin kayo na derivative, we can actually express this and this one. So, we have n squared, n1 squared times p raised to n1 is just this one. So, we have derivative ng square, derivative siya ng partial derivative ng p raised to n1. So, kung titingnan nyo kasi, di ba pwede natin gawin itong n1 p raised to n1. Tama? And this one, ito yung pinakita natin expression kanina, which is this one. Ngayon, multiply mo na siya ng another n1, no? Tama? So therefore, pwede pa nating, since i-derivative mo pa ito, you will have the mas compact na expression. So i-square mo yung partial derivative mo, tapos i-derivative mo yung p raised to n1. Okay? So lagyan natin dito, no? So tandaan nyo, in-express natin ito, no? And then n1 is just p partial p. So palitan mo to, kakaroon ka ng double. Alright? So ngayon, yung equation natin kanina can now be expressed this as follows. So we have, magiging ganito na lang siya. Alright? And we can further remove that from the summation. So ito, essentially, is just, ito nga, p plus q raised to n. And then ito na yung mangyayari. So ngayon, pwede natin i-factor to as dalawa. So what you have to do is to operate this one first. So i-derivative mo, you will have this one, which is the same as yung sa average ng n1. And then, pwede nating i-derivative itong buong to, no? So treat this as a product. So you have this one and this one. So derivative niya, so yung p, itong factor p na to, nandito lang siya. Derivative mo is ito muna. So you have this one. Multi-derivative niya is ng p, with respect to p is just 1. Tama? And then the other one is p times derivative ng buong to, which is n minus 1, p plus, this should be q, right? Hold on. Yeah. Yan, typo pala yan. And then n minus 1 is n minus 2. Okay? So, natuloy natin. Okay, nasa bawata ako dito. Dapat q to. Alright. So, ngayon, expand lang natin yon. Tawag dito. So, nandito pa rin yung factor p, sorry. Yan pa rin yan. And ito, similar do sa kanina. However, do take note of this one. This is p plus q. This is equal to 1. Alright? So, mangyayari ngayon, since kahit ano pang exponent yan, 1 pa rin yan. So, wala na yan. So, what we have is still yung p. Ito, magiging din, no? 1 din. So, n na lang. This one is pn times n minus 1. So, ito na yung matitira. Okay? We can factor out n, kasi may n lahat, no? And then we have np times 1 plus pn minus p. Okay? Ito yan. So, pwede natin multiply na. We have np plus np squared, yung buo, and then np squared. Right? So, pwede nating i-arrange. So, sulat natin yung np squared muna, and then np minus np squared. So, pwede natin i-factor dito yung np. So, we have 1 minus p. So, remember, 1 minus p is just q. So, we have np squared plus npq. Alright? So, therefore, ang second moment natin is just np squared. So, remember, ang average ng n1 is just np. Therefore, n1 bar squared is np squared. So, palitan lang natin. Okay? So, now, the n1, the square of n1, average na is just n1 mean square plus npq. Okay? So, ito na yung natin. Therefore, makukuha natin yung second moment. Di ba yung second moment is defined by the square of the variable mean nun minus square ng mean. Okay? So, ito yan. So, therefore, tawag dito, pinakita natin kanina yung value nung i-subtract lang natin, no? So, we have lagay natin. So, we have ito is n1 bar squared plus npq. Then, ma-minus natin ito, which is n 1 bar squared. Mawala yan. We have NPQ. So yan yung second moment natin. Okay? So ganun lang yung ganun lang yung sa pagkuha ng second moment. Okay? I-take note ko lang para hindi kayo kasi nag-iiba yung variable, no? Para makuha mo yung second moment, you have to get the mean kasi i-square mo pa yun, and you have to get the square ng mga variable, yung average nun. So una natin ginawa, sinolve muna natin yung N1, yung average, which is ito, NP. And then, ginawa natin yung itong unang term dito, which is much complicated kasi second derivative. Okay? So, naipakita natin ngayon na ito yung second moment. You can still get the third moment. Halimbawa, sabi example. Yan, halimbawa dito. Pwedeng N1 cube bar. So, magiging 3 lang ito. And of course, in this case, you have to manipulate this to get magkakaroon ka somehow ng third derivative. So, 3 beses, which is much complicated. Okay? So, yan ang discussion natin muna ng 1.5 and 1.6. Sorry, 1.5 lang muna. Sorry. Yung 1.6 is, ano naman yung mangyayari kapag we are dealing with probability distribution with large N. No? Kung titingnan niyo yung example kanina, sa previous natin na diniscuss, dun sa ito, we have discrete probability distribution. Bakit discrete? Kasi nga, naka-ano lang siya. Hindi siya continuous, and we have, for each particular whole number, may given probability. This is for n is equal to 20. Now, the question is, what happens if n approaches infinity? Anong mangyayari? Okay, so we will discuss that later sa next na discussion, which is yun nga, probability distribution for large N for section subsection 1.6. Okay, so isasabihan ko na lang yung correction. Nandito rin naman, pero i-correct ko yung dito may mali dito dito. Okay? Okay, so yun muna, and thank you sa pakikinig. Hopefully nakita nyo kung paano yung step-by-step process ng pag-derive nitong mga general expression. So yun lang muna. Thank you and have a nice day.